we're going to finish up chapter 6. We have 2 sections, well, 1 section left, but 2 days on it, 6.8 day 1 and 2. And this will be looking at how you can expand binomials without having to FOIL a ridiculous amount of times. It's a shortcut. One way will be Pascal's triangle, which we'll learn today, and then the other will be the binomial theorem, which we'll learn tomorrow. So this little discovery activity, I've already FOILed them all out for you, but you can see that I have x plus 1 to the 0 power, x plus 1 to the first power, x plus 1 to the second power, which needs to be expanded and then FOILed, x plus 1 to the third, and x plus 1 to the fourth, where you would expand it 4 times, then you'd have to FOIL. Okay? We're going to notice a pattern amongst the coefficients of these terms. So this one was a 1, this is a 1 and a 1, this is a 1, a 2, and a 1. This one gets me 1, 3, 3, 1. And this one gets me 1, 4, 6, 4, 1. Does anyone notice any patterns among the coefficients? I'm just going to write them out without any variables attached to them and see if you notice any relationships or patterns amongst the coefficients. See a pattern, how we could continue this to come up with the next row. Jade?
The 2 numbers above it add together.
Good. The 2 numbers above it are added together. So 1 plus 1 gets you 2. And it does have to have 2 numbers above. 1 plus 2 gets you 3. 2 plus 1 gets you 3. 1 plus 3 gets you 4. 3 plus 3 gets you 6. 3 plus 1 gets you 4. So if you wanted to continue, now the outside numbers will always be 1 and 1. We would get 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. 4 plus 1 is 5. So it'd be 1, 5, 10, 10, 5, 1. So you can do this, and this is called Pascal's triangle, to expand a binomial. Let's say if we wanted to do something like x plus 1 to the 10th power. And you did not want to have to do x plus 1 written out 10 times and then FOIL it, I don't know, a handful of times. You can use Pascal's triangle, and what it will do for you is it will give you what the coefficient of the final expression will be. And then you'll just attach your x to the fourth, x to the third, x to the whatever it might be. So Pascal's triangle is something that you'll want to remember how to do the first few rows. You need to memorize probably the first 3 rows, and then you could come up with the other ones. Although many of you will remember like up to the 5 because they kind of have a pattern. So it's a triangular array of numbers formed by first lining the border with 1s and then placing the sum of the 2 adjacent numbers within a row between and underneath the 2 numbers. So if we have something to the 0 power, this is our 1. We already saw this one was 1 and 1. This is our 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. We just found the other one. See if you guys can complete the other few rows by following the pattern that it is the sum of the 2 numbers above it. Remember, it will be bordered with 1s on the beginning and the end of each of those. Usually, I won't give you ones that are much higher than 8. I could give you up to something of 10, but you again want to make sure that you memorize. Probably I would memorize these just because they show up so much. That way you don't have to come up with the triangle every time. You'll just memorize them and know that if you have something to the 5th power. Now you do want to realize that this row, this is like row 0. This is row 1. Some students think it automatically assumes that it would be row 1, row 2, row 3, but it does start with row 0, row 1, row 2, and that's going to tell you what your exponent is outside of the binomial. So in the back, we're going to practice expanding some of these using Pascal's triangle. Some of them will be easier than others. So if they are just A and B, then you are just going to use Pascal's triangle to come up with the coefficients. Now you do have to figure out what the arrangement of the variables and exponents will be also. We know that they go in descending order, like usually x to the 5th, x to the 4th, x. But when there's two variables, if there's an a and a b, we have to look at how we're going to kind of distribute those. I'm going to give you a handout tomorrow with this, because I apparently didn't copy my Pascal's triangle, but I have, maybe I'll copy this one for you. It has up to row 12 filled in for you, but of course you won't get to use this on a quiz or test, but you can have it in case you wanted it. All right, so we're asked to expand these using Pascal's triangle. So we can notice that this is our 5th row. Which the 5th row had coefficients of 1, 5, 10, 10, 5, 1. Okay. Now those stand for your coefficients. What you have to remember also is that we have two variables. We don't, on the front, one of my example for the discovery was like x plus 1, so we only had one variable. When you have two variables, you're going to actually start with the highest one first. So this would be 1, a to the 5th. Technically, it's b to the 0, but we know b to the 0 is really 1. Now, since it's a plus, we will continue with positives, so plus 5. Now, the a variable will decrease one value, so a to the 4th. The exponent for the b will go up 1, so b to the 1st. Bring down our next coefficient, which is a 10. We'll have a to the 3rd, b to the 2nd. Remember, the sum of your exponents is always going to get you back to 5. Plus 10, a to the 2nd, b to the 3rd. Plus 5, a to the 1st, b to the 4th. And plus 1, a to the 0, b to the 5th. Now you would want to simplify that down, and normally I won't write the b to the 0 because I know that's 1, but we will need to get rid of those before we have a final answer. So this is just 1, and this is just 1. So our final answer would be a to the 5th plus 5 a to the 4th b plus 10 a cubed b squared plus 10 a squared b cubed plus 5a b to the 4th and plus b to the 5th. See if you guys can try number 2, and then we're going to make it a little bit harder on number 3. So this one is our 8th row. So again, you may want to flip back to the front of your paper to see what your 8th row was for Pascal's triangle. This will obviously be a long one. The higher the exponent, the longer the expression will be. Make sure that you are appropriating your exponents. Space, so I just came down on the second line. So double check this with what you have on your paper. Again, you can also double check your exponents. The sum of the two always have to get back to 8 just to make sure you didn't somehow mix one up. But as the A decreases, the B increases. Now, what gets harder is when they're not A's and B's, when they're actually numbers and other variables. So you always want to think the formula is A plus B to the whatever power. So you have to identify what A and B are, and then we're basically going to substitute them in still using Pascal's triangle. This one's not so bad because it's a 4th power. But the A value in our expression is actually x. The B value is a -2, okay? Which means whenever we plug the B in and we raise it to like the first, the second, the third, we have to actually evaluate -2 to the first, the second, the third power. All right, so you can start out with your regular Pascal's triangle, which would be your 1, 4, 6, 4, 1. Okay. Now, it's normally 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus 1 b to the 4th. And then what we're going to do is we're going to substitute in what A and B stand for. And we're going to have to do a little bit of evaluating. You can actually skip this step if you want and just substitute in the values, but I like to show it in the notes. So A is actually x, so this is going to be 1x to the 4th, which is just x to the 4th. Plus 4, A is x, so that's x cubed. Now be careful, B is a -2, so I would use parentheses there to plug in the -2. Plus 6a squared, which would be x squared. You don't really need the parentheses around the x, but sometimes I do it anyways. And then b squared, you do want to have parentheses around this one, -2 squared. Continue on, plus 4a, which is x, b cubed, which would be -2 cubed. And last but not least, plus 1b to the 4th, which would be -2 to the 4th. Now before you move on and do anything else, you want to evaluate all those -2's to whatever power. So this is really just -2. This one is going to get me a +4. This one is going to get me, is it going to be +8 or -8? Here, -8. And the last one will get me a +16. -2 times -2 times -2. All right, now we simplify. So this would just be x to the 4th. Now in my second term, I need to actually multiply the 4 and the -2. So actually, let me go back. It should not be a plus. It should be 4 times -2, which will be a minus 8x cubed. Multiplying the 4 and the 2 together, get -8. All right, next term, I need to multiply my 6 and my +4, which would be a +24 x squared. Next term, I have a 4 and a -8, which will get me a -32 x. And at the end, I'll get a +16. Does not say we have to write an equation, it just says we're writing expanding. So it's not going to have our equals 0 or our y equals. All right, let's try the last one. I'll set it up for you, and then I'm going to let you guys finish it out. So again, this one we're going to do, this is our a plus b to the 4th, which if you want, it's the same thing as what we have above, if you don't want to rewrite that step of it. Okay. But in this case, a is x, and b is a -3. So we would have 1, this is again our 1, 4, 6, 4, 1 pattern. So we have 1, a to the 4th, which is x to the 4th, b to the 0, so I won't write it, plus 4 x to the third. And now I'm going to use my parentheses because this is going to be b to the first, which is a negative 3 to the first. Plus 6 x to the second, b, which is negative 3 to the second, plus 4 x to the second, x to the first, times negative 3 to the third. And lastly, plus 1 x to the 0, negative 3 to the fourth. See if you can simplify all of your exponents and multiply them by the original coefficients to get your final expansion. Take a look up here and see if yours is matching mine. Something you will notice, and a lot of students remember this, is that whenever it is a subtraction inside your binomial, it will alternate positive, negative, positive, negative, positive, just so you can kind of check that at the end to make sure you didn't screw up a sign somehow. If this were to be x plus 3, you would just plug in a positive 3 for all of your b values, and then you would get all pluses instead of toggling the positive, negative, and positive. All right, your homework is done on Google Classroom tonight. I think that you need possibly the 10th, no, the 9th row of Pascal's triangle. So while we're here in class, you might want to go ahead and go back to the front, and you might want to add in a 9th row just so you have it. Then that way you can use it on your homework because you'll need that on one of the questions.